Today we discuss the new topic, that is stress strain curve, or it is also called the behavior of wire under increasing load. Suppose we consider a wire, metal wire, and one end of metal wire is fixed and the other end of metal wire is attached to the hanger, and this hanger is slotted or changes the different weights. Now if we apply the load on that wire, the wire changes, or we observe that the length of wire is increases and diameter of wire is decreases, and this load is increases by half kg. 1 and 2 reading, we observe that if we added load, the wire is its length of wire is increases, and if we remove this weight, the wire regain its original position. But at certain limit, if we add the weight in this wire, 6 or 7 reading, then we observe that if we remove the weight, the wire cannot get its original position. That is, up to elastic limit, the wire acts as a elastic behavior, or wire shows elastic property, and beyond elastic limit, wire shows the plastic behavior, or wire get change, or there is permanent change in this wire. And this behavior of wire up to first reading, second reading, third reading, up to so on, up to the wire is break. आपण कुठपर्यंत रीडिंग घेणार आहे की अर्धा किलो वेट ऍड केलं, थोडंसं लेंथ वाढेल, आणखी अर्धा किलो ऍड केलं, असं अर्धा किलो आपण वाढत गेलं तर एक स्टेज अशी येईल की वायर ब्रेक होईल. तोपर्यंत आपण रीडिंग घेणार आहे. 1-2 रीडिंगला आपल्याला असं लक्षात येतं, 2-3 रीडिंग मध्ये की वेट ऍड केलं, लेंथ वाढते, ऍड केलेलं वेट आपण काढून घेतलं की परत ती वायर ओरिजिनल लेंथला जाते. हा एक सेक्शन. आणि लिमिट क्रॉस केल्यानंतर मग मात्र परत ती वायर कांट गेट इट्स ओरिजिनल पोझिशन. अँड दिस बिहेवियर ऑफ वायर अंडर increasing load shows the change in stress and change in strain, and this stress and strain, if we plot a graph of stress versus strain, the strain along x-axis and stress along y-axis, and this graph, that is stress strain graph, gives the behavior of wire. Now the first portion or initial portion of wire, that is OA, the initial portion of wire, that is OA, shows in that portion, if we increase stress, the stress is directly proportional to strain. The initial part or initial portion of this graph or curve, that is OA, shows the stress is directly proportional to strain, and Hooke's law is valid or obey. Hooke's law is valid or obey. Also, this portion OA shows the elastic behavior. Elastic behavior. The first portion of wire, that is initial part of graph, shows the Hooke's law is obeyed, or trace is directly proportional to strain, and hence this portion shows the elastic property or elastic behavior of the given material of wire. Now, second point, at point A, OA, and exactly at point A, the trace is directly proportional to strain. Hence, that point is called proportional limit. The point A is called proportional limit because at that point, or up to OA, or at point A, the trace is directly proportional to strain. Hence, that point is called proportional limit. Now, second point, if we increase the load, up to point B, or to reach the point B, if we further increase the load, we observe that stress and strain, the quantity trace and strain, are not longer to show the property, that is, stress is directly proportional to strain. Beyond point A, if we increase the load, the trace is not proportional to strain, and Hooke's law is not valid. Hooke's law is not valid up to point B. There is, or up to point C, the portion A, B, C. This portion gives, if we increase the load, the trace is stress and strain not shows the directly proportionality, and hence the Hooke's law is not holds good, or Hooke's law is not obeyed. Now, at that point, if load is removed, increasing load, and that load is removed, then the wire get its original length. Hence, that is called elastic behavior. And at point C, the wire shows the plastic behavior, and we observe the portion EC or CE, and that portion shows the plastic behavior of wire. Because if we increase the load, the Hooke's law is not holds good, and we remove the load, then at point C, the wire cannot get its original position, that is, the wire crosses the elastic limit, and this wire, as in plastic behavior, and this portion EC shows the plastic behavior or plastic property of the wire, and in this wire get the permanent change, and that is called the permanent set. At point E, that point E is called permanent set, because the wire cannot get its original length. त्या वायर मध्ये जो बदल झाला तो परमनंटली झाला, म्हणून बी पॉइंट पर्यंत ती वायर ओरिजिनल पोझिशनला येते, पण सी पॉइंट पासून ती ओरिजिनल पोझिशनला जात नाही, त्याच्यामध्ये परमनंट चेंज झाला. म्हणून ॲट पॉइंट ई और ईसी इज कॉल्ड प्लास्टिक बिहेवियर, and that particular point E is called permanent set. Hence, that point B is the elastic limit. up to point OB. This OB shows the elastic behavior, but this BC portion is cross the limit, or at point B this is the exactly elastic limit. हा पॉइंट B जो आहे, ह्या पॉइंट B च्या अगोदर वायर मध्ये इलास्टिक प्रॉपर्टी असते आणि B पॉइंट च्या पुढे वायर मध्ये प्लास्टिक प्रॉपर्टी निर्माण होते. म्हणजे OB पर्यंत त्याच्यामध्ये इलास्टिक प्रॉपर्टी असते आणि B पासून पुढे गेल्यानंतर त्याच्यामध्ये प्लास्टिक प्रॉपर्टी तयार होते वायर मध्ये. म्हणून B पॉइंटला म्हणायचं इलास्टिक लिमिट. द पॉइंट B इज कॉल्ड इलास्टिक लिमिट, और इट इज आल्सो कॉल्ड यील्ड पॉइंट. द पॉइंट B is also called yield point. The beyond yield point, the wire is shows plastic property, and up to yield point wire shows the elastic property. Now the further increasing load, we observe that the strain is increased very fast, but stress is increased slowly. Beyond point C च्या पुढे if we apply load, the strain increases fast, but stress increases slow. Up to point beyond point C, if we increase the load, stress increase slowly and strain increase very fast up to point D. Hence the portion CD. Hence the portion CD or portion B to D. The portion C to D or B to D, it shows the plastic flow or plastic deformation in this material of wire. From point B to D, there is permanent change in the wire due to increasing load, and if we increase the load, the strain increases very fast, stress increases slowly. Hence point B to point D, that portion of wire shows the plastic flow, or it is called plastic deformation. And at point D, finally, that is called fracture point. At that point, the wire is break. Hence, that D point is called breaking point or fracture point. At that point, the wire is break or fracture. D या ठिकाणी जसजसा आपण लोड वाढत जाऊ तर वायर तुटते आणि तो पॉइंट म्हणजे D आहे. D या ठिकाणी ती वायर तुटते and that point is called fracture point or breaking point. This is about the behavior of wire or stress strain curve explanation. This is first portion OA, shows the elastic property, that is stress is directly proportional to strain. Hooke's law is obeyed. Then the another portion A to B is also, if we remove the load, wire get its original position, that is OB portion gives the elastic behavior. Beyond point B, the point B is called elastic limit or end point. Beyond point B to D, the wire shows the permanent change and plastic behavior. Wire shows plastic behavior, and from point B to point D, the wire shows plastic flow, and the deformation of wire is called plastic deformation. And finally at point D, the wire is break or fracture. Hence that point D is called fracture point or breaking point. Now also we define some definitions about the material and that material shows the plastic and elastic behavior of. The first definition is brittle. Brittle means the material of wire or metals. The material of wire or metal such as the material, the first definition, brittle, the material such as glass, ceramics. This material, for example glass or ceramic, that material is break. That material is break or fracture within elastic limit. Within elastic limit, that is at point B. म्हणजे ग्राफचा आपण विचार केला तर पॉइंट O B shows the elastic property and elastic limit at point B, that is the material such as glass or ceramic break within elastic limit. ते B point A च्या अगोदरच break होतात, तुटतात. That material is called brittle, or such a material is called brittle. Second point, ductile. The second type of material is ductile. The material such as copper, aluminium and iron. The materials such as copper, aluminium and iron have large plastic range of extension, hence they lengthen considerably and undergoes plastic deformation till they break, and that type of material is called ductiles. In our stress strain curve, there is wire made from iron or steel. आपण जे आता डायग्राम काढली होती ती वायर आपण मेटलची होती, एकतर ते स्टील मटेरियल असेल किंवा आयर्न असेल. जर असं मटेरियल असेल तर त्या मटेरियलमध्ये जर आपण लोड अप्लाय केला किंवा अशा मटेरियलची कॉपरची, ॲल्युमिनियमची किंवा आयर्नची किंवा स्टीलची वायर असेल तर आपण त्याच्यामध्ये लोड अप्लाय केला तर तो बियॉन्ड इलॅस्टिक लिमिट म्हणजे बी पॉइंटच्या पुढं जास्त वेळ त्याच्यामध्ये इलॉंगेशन आपल्याला पाहायला मिळतं आणि सगळ्यात शेवटी डी या ठिकाणी तो ब्रेक होतो. अशा पॉइंटला म्हणायचं डक्टिटाईल. आणि ब्रिटल म्हणजे काय, तर ब्रिटल बी पॉइंटच्या अगोदरच म्हणजे इलॅस्टिक लिमिटच्या अगोदरच तो मटेरियल ब्रेक होतं किंवा क्रॅक जातो. असं मटेरियल उदाहरणार्थ ग्लास अँड सिरॅमिक इज कॉल्ड ब्रिटल. डक्टिटाईल हे मटेरियल बियॉन्ड इलॅस्टिक लिमिट, बी पॉइंटच्या पुढे बराच वेळा त्याच्यामध्ये त्या मटेरियलमध्ये चेंज होत जातो, त्याचं डिफॉर्मेशन आपल्याला पाहायला मिळतं आणि मग फायनली डी या ठिकाणी तो ब्रेक होतो. अशा मटेरियलला म्हणायचं डक्टिटाईल. अँड थर्ड मटेरियल इज कॉल्ड Malleable is the material such as malleable is the material such as gold, silver. जर गोल्ड मटेरियल असेल किंवा सिल्वर मटेरियल असेल, जर आपण ह्याच्या हॅम्बरिंग केलं, याच्यावर हॅम्बरिंग केलं किंवा याच्यावर काय आढळलं किंवा अशा प्रकारचं गोल्ड मटेरियल असेल किंवा सिल्वर मटेरियल असेल, त्याच्यावर आपण हातोडीने जर मार गेला तर त्याचे असे लहान लहान सीड्स तयार होतात, स्मॉल सीड्स, and that type of material is called malleable or malleability property shows that type of material. When such material or metals such as gold, silver, which can be hammered into thick or small sheets, and such property of material is called malleable. These are the three properties of material shows up to elastic limit or beyond elastic limit.